We have used algebra to solve equations with numbers. In this video and set of videos, we're going to discuss one step further, and that would be learn how to use algebra to solve equation with functions. Which functions? Real number functions. Right? We have seen real functions are functions with input and the output, that is the domain and the range, having set of real numbers. Right? So we're going to look into addition, subtraction, multiplication with scalar and with another function, and the quotient of two real function. Okay, so we're looking at addition of function. See, these are all the technical aspect, right? I'll just show you guys the important things over here and I'll come back to this. So here we have function mapping, that is function f mapping x to r, set x to r, and r is again a subset of real numbers, and g is mapping x to r, and x again is a subset of real numbers. That's why these are your real functions. Now we are looking at f plus g of x. Okay, so basically we're looking at the resultant function after solving f and g's algebraic addition and all of that. The resultant function is being mapped, is going to map set x to r. Right? What does it mean exactly? Here I have f of x being equated to x square and g of x being equated to 2x plus 1. Right? So we have to figure out f plus g of x. And this is nothing but as per the formula f of x plus g of x. Don't worry, we are going to understand what is it exactly we are looking at, So first thing first, what is f of x and g of x? This is nothing but x square plus 2x plus 1. Now what the concept is telling is, you can simplify this further. Make your job easy. What can we do with this? Anything that triggers your mind? Yes, it's of the form a square plus 2ab plus b square, and that's nothing but, yes, a plus b the whole square. Okay, makes sense? Right? So I can rewrite this as x plus 1 the whole square. Is it not? But what is the basic idea over here? I mean, why is that we are doing it, and what is the point of this, and what is the exact difference? See, it's about the sequence of how we handle input, right? So let's understand this with the need of whatever we are doing. The sequence. There are two ways that we can say for an input of 2, right? I can individually take in this idea of taking in 2, right, and resolving f of x plus g of x. I can put this input 2 into f of x separately and g of x separately. So what is f of x? This is x square. What is g of x? This is 2x plus 1. Okay. So what is 2 square? 4. What is this? 5. Right? What is the answer? 9. Agree? Okay. And now on to the second way. What is the second way? The second way tells that is the whole idea of this topic. I can simplify this, right? And then I can say this is a simplification addition, and this is your simplified form, that is your x plus 1 the whole square. So if I give an input of, say, in this case 2 only, obviously we're taking 2, what will I get? So 2 plus 1 is 3, 3 square is 9. In both the cases we got 9. So that's good. So what is the big deal? We're getting the same answer, but why is that we have to add the function simplify and all of that? Well, to understand this better, let's go to the one of the actual usage, right? Where do we use it? We use it in our programs. Okay, expressions are used in our programs. So I have the functions over here, not over there. Here, f of x is nothing but x square, right? That's your first function. Second function is 2x plus 1. So I can do two ways. First way is I can find the answer individually, like a and b is equal to f of x and g of x, and then I can add, right? So it returns the sum of f of x and g of x, but finding the value of f of x and g of x individually. Then we have x plus 1 the whole square, that is f of g of x. So what is that I'm going to do is I'm going to find the values of 0 to 99 using something called as time it. Okay, it's going to time a particular behavior or a code. Okay, so the funda over here is this time it, this particular class is going to help us find the time that the system requires to do something, right? And it will do the same job how many times? 1 lakh times, and take the average. Okay, so you don't have to get into the whole gist of it. I mean, the whole idea behind it is going to be complicated. Actually not complicated, but yeah, it's going to be lengthy. No point over here, right? So we are basically timing it by running it 1 lakh times for each input. If you guys understand, good. If not, it's okay. So basically we're going to find the time difference taken to do this on, say, around 1 crore inputs. That's what you guys can think of. And same 1 crore inputs is going to go through this, right? Okay, I took a single input and I showed you guys the system is going to do 1 crore times. So it was going to take around 5 seconds actually, because I run it, you know. So I think, yeah, 5 seconds I guess by now. Yeah, it did. So it's giving us two versions of things. One is, I'll show you guys. This is the total time taken by f of g of x. That is a simplified form. That is, it's going to take 2.45 seconds. 1 crore of input values. It took to simplify 2.45 seconds, while doing the first way, that is finding the input for individual function and then adding up, it took around 3.84 seconds. So there's a difference of 1.3 ish, right? 1.29 actually. But point is, it took so much of time. There's a time difference, is it not? Huge difference. And that's why we learn this. One of the reasons, of course, there are a lot of reasons. So for more complex things, it's a similar reason, to be honest. But yeah, you got the difference, right? So you can see the time difference on an individual scale. So we can see that if I give an input of say 20, it took around close to 0.025 seconds. While for the same input, this black color things are the first way. Okay, so let me make it clear. First thing is what is that we are looking at? That I need to make clear. I can't just start talking about it. Right, this is a time difference graph. That's the title. So we're looking at time versus the domain value. Basically, instead of x value, I can call it as domain. So the set of values from 0 to 99, right? So the 99th value going through the second way, this is our second way, it took around approximately 0.025 seconds. While in the first way, it took around 0.038 seconds. So that's the average which we saw, right? So this is the individual values graphical view, time basically, how much time it took. So you can see clearly that each value, exceptions are there. If not, we can see that each of them are almost on a linear set of lines. This being one and this being one, so on and so forth. So basically you can see the difference. So the need is that using this fact or this behavior, right, we can simplify things and make our job a lot easier. Okay, so that's the difference. This represents the resultant of what this expression this expression talks about the resultant. Okay, resultant expression, simplified form. While this tells that, okay, take the input individually and then simplify. An important fact that you are going to use in your competitive exams and 1 marker questions. So the domain aspect. Okay, the domain of the resultant function is going to be a what is this? Yes, intersect between domain of the first function and the domain of the second function. So it's going to be intersect, right? Whatever the common domain is, that will be the domain of the resultant function. Okay guys, that's the whole funda. Similarly, I've shown the subtraction also. It's the same thing. So in subtraction, what is that we are looking at? The same thing, two functions mapping x to r, and x is a subset of r. Subtraction between the function is f of x minus g of x, and so on and so forth. You know, we can subtract it. Basically, let me show this. So we have two functions. If I have to find f of g of x, f minus g of x, f minus g of x, all I have to do is x square minus of 2x minus 1. So this would be x square minus 2x plus 1, and this in turn is x minus 1 the whole square, right? So instead of the first way, we can go with this way. The resultant expression, we can make use of it. And here too, the domain of the resultant function is an intersect of the first two functions, right? It's very important for us to know the domain of a resultant function. Okay guys, so now it's time for you guys to execute the set of codes, understand the concept. So this would be your heading. The remaining videos, remaining topics I'm doing in the next video. So for now, you guys start off with this.